That's great. So we will start the class. Okay. Yeah. So good evening once again to all of you. So we are discussing about the redox reactions, right? So we have discussed the definition for reduction and oxidation and the rules for finding out the oxidation number, the definition for oxidation number, all those things we have discussed so far. And in the previous class, I gave you one homework, right? So do you guys remember? Have you solved? So I have given S4O62 minus ion, which is called as tetratiamate ion, as an homework for you. And I have asked you to find out the average oxidation number of sulfur and the oxidation number of each sulfur in the compound, right? So did you guys get the answer for this question? What is the average oxidation number of sulfur that you got for this? What is the average oxidation number you guys got for this of sulfur? Is it 4? Oh. Okay, let us check. Let us check. So let me take the oxidation number of sulfur as X. Okay, so we have 4 sulfur and 6 oxygen. So each oxygen carries -2 charge, right? Okay, let's check. Let's check. So it is 4x plus -2 into 6, which is equal to -2. So this -2 is nothing but the charge of the ion. This is the charge of the ion. Okay, and if you solve this, you will get the X value as 2.5. Okay, so the average oxidation number of sulfur is not 4 or 6, it is 2.5. Clear? So now let me give you the structure. So this is the structure of this molecule. S4 and O6. Okay, sulfur, you all know that it is a 16th group element. So mostly it forms 6 bonds and in some case it forms 2 bonds. So the valency is 6 and 2, right? So like oxygen, it forms 2 bonds or 6 bonds. Okay, so this is the structure. O6, 2 minus. So 2 oxygens are carrying the minus charge, negative charge. Now let's see the oxidation number for each element with respect to the bond and its electronegativity. Okay. So let me first take the S double bond O. So oxygen is more electronegative compared to sulfur. So oxygen will gain the electron. So since there are 2 bonds, it will gain the 2 electrons. So -2 for oxygen. And since sulfur is donating, it is +2. Okay. And with respect to the sulfur oxygen single bond, it is -1 and +1. And here -2 and +2. And coming to the sulfur-sulfur bond, both the bonded atoms are same. So there is no charge separation. It is 0. And for the second sulfur-sulfur bond also 0. For the third sulfur-sulfur bond also it is 0. Okay, then for the other side, it is the same. -2 + 2, -1 + 1, and -2 + 2. Got it? So this is the separation of the charge. So now, coming to the oxidation state of the first sulfur, oxidation number of the first sulfur. So what it is? So the sulfur is having +2, +1, +2 and 0 around it. So what is the total charge acquired by sulfur number 1? +2, +2 and +1. So it is +5. So the oxidation number of the first sulfur is +5. And for the second sulfur, both of them are 0. So it is 0. And for the third sulfur also, it is 0. Yeah, very good. Very good. The third sulfur also gets the 0 charge, right? 0 plus 0, so 0. What about the last one? The fourth sulfur? It also has +2, +2 and +1. So the total charge is +5. Okay. So the first sulfur and fourth sulfur are having +5 charge. Very good. Very good, Bindu, and very good, JNV. I don't know your name. So please mention your name. It is just JNV. So the in between sulfur, the second sulfur and the third sulfur are carrying the zero charge. Got it? So plus 5 means plus 10. So 10 plus charge is shared by 4 sulfur, right? So the each sulfur, the average oxidation number of sulfur will come out to be 2.5. So 4 sulfur are there. They are carrying, they are sharing plus 10 charge. So it will be 2.5. 10 by 4 is 2.5, which is the average oxidation number of sulfur in this compound. All right. So with this compound, we are ending the special cases. Okay, in the previous class itself, we have studied many special cases. And this is the last compound under this topic. And the next topic is stock notation. So it's very easy. So Stock, the scientist named Alfred Stock, he used one notation to represent a compound. Okay. So let me give you some examples. So first I'm taking stannous chloride. So stannous chloride is represented as Sn, open the bracket, 2 charge plus 2 charge and close the bracket and Cl2. This is stannous chloride. This is the Stock notation of stannous chloride. And for stannic chloride, it is Sn plus 4 chloride, Cl4. So what he is trying to do, he is mentioning the oxidation state of the element inside the parenthesis, inside the curved bracket. Okay. So in case of SnCl2, what is the oxidation number of this tin? Tin is taken as X and we have 2 chlorine. For each chlorine, the charge is -1. For 2 chlorine, it will be -2. So X is equal to +2, right? So this +2, the oxidation number +2 is denoted with a Roman numeral inside the curved bracket next to the element. All right. So this is called as stock notation. This is called as stock notation. Very easy. If they are asking in your examination, they are asking you to find out the stock notation for some other compounds. What compound we can take? Yeah. If they are asking you to find out the stock notation for PCl5, what will you do? You will find out the oxidation state of phosphorus. So what it is? It is +5, right? So it is +5. So we will write phosphorus 5 inside the bracket and Cl5. So this is the stock notation of this compound. Got it? This is how you have to find out. Clear for all of you? Shall we go for the next? Shall we go for the next? Sandhya, Sneha, Meenakshi, can you all able to understand? Jaini, Shimoga, Kartika, Bindu. Yes. Oh. So now, in the next slide, we are going to see another definition, one more definition for oxidation and reduction. So already we have studied 3 definitions, right? But 2 in terms of classical concept and 1 in terms of electronic concept, electron transfer concept. So now we are going to learn one more definition for oxidation and reduction. So that is for oxidation, increase in the oxidation number of the element in a given substance. And reduction is decrease in the oxidation number of element in the given substance. What is oxidation? If you are having an element and if the oxidation number of that element is getting increased, it is called as oxidation. If it is decreased, then it is called as reduction. So I will give you some examples in the next slide for this. Okay. So before that, I would like to define 2 more terms which are very important. Okay. So the very first term is oxidizing agent, which is otherwise called as oxidant. Oxidizing agent is a reagent which can increase the oxidation number of the element in a substance. And reducing agent is a reagent which can decrease the oxidation number of element in the substance. Okay. We all know that redox reaction is a reaction which involves the change in oxidation number, right? So now let us see about the oxidizing agent and reducing agent using one example. Okay. So this is the example I have taken. Now, if you find out the oxidation number of each element present in this compound, you will get the oxidation number values like this. Okay, for copper oxide, for Cu2O, if I want to find out the oxidation number of copper, it will be 2x minus 2 equal to 0, right? So each oxygen will carry minus 2 charge. And since we have 2 copper, I have taken 2x. So 2x is equal to 2 and x is equal to plus 1, right? So the copper oxidation number is plus 1. And we all know that oxygen oxidation number is minus 2. It is minus 2. And here also it is plus 1 and minus 2 for sulfur. Oxygen and sulfur both belongs to the same group, right? So both will have same charge. And here copper is in elemental form. We have studied under the rules, right? The very first rule is all the elements in its uncombined state will have oxidation number as 0. So the copper is having 0 state. And here in sulfur dioxide, if I take sulfur as X and oxygen, each oxygen carries minus 2. We have 2 oxygen. So 2 into minus 2 is minus 4, which is equal to 0 and X is equal to plus 4. So plus 4 is the oxidation state of sulfur in this compound. Do you have any doubts in finding out the oxidation state of each element in this reaction? Do you want me to explain for any compound? Is it clear to all of you? Shall I go for the next step? Students, please do give your answer. Say yes or no. So if you want me to explain once again for any compound, you can let me know. Everything is clear, right? All of you can able to understand how to find out the oxidation number of each element, no? Okay, great. So now let us study some more points. Now you look into the oxidation state of each element. Let us start with sulfur. Oxidation state of sulfur in the reactant side is -2 and in the product side it is +4. What is the meaning of this? From -2 to +4 means it has lost its electron or gained its electron. Or tell me whether the increase in oxidation number takes place or decrease in oxidation number takes place. -2 to +4. You can take the number line also. -1, -2, and here we have +1, +2, +3, and +4, right? So the sulfur is moving from -2 to +4. So it is obviously increase in the oxidation number of this sulfur element in the copper sulfide compound. Right? Very good, Bindu. So oxidation number increases. So if there is increase in the oxidation number, it is called as oxidation. So sulfur has undergone oxidation. Okay. Now you look into the copper. So copper is in +1 state in the reactant side and it is moving to 0. So +1 to 0. So what it is moving towards left side, right? So what is happening here? There is a decrease in the oxidation number. So if there is a decrease in the oxidation number from +1 to 0, it is called as reduction. It is called as reduction. Okay. Clear? The reagent which increases the oxidation number is called as oxidizing agent, and the reagent which decreases the oxidation number is called as reducing agent. So copper 1 is the oxidizing agent and sulfur in copper sulfide is a reducing agent. Can you all able to understand? So sulfur is reducing the oxidation state of copper. So this is the reagent which decreases the oxidation number of the element in the substance. Okay. Clear? Can you all able to understand the oxidizing agent and reducing agent topic? Or if you want me to give a very simple definition for oxidizing and reducing agent, I can give you like this. Oxidizing agents are electron acceptors, and reducing agents are electron donors. Okay. So here sulfur is moving from -1 to 4. Means it has lost its 6 electrons. It has lost its 6 electrons. So electron donor. It is acting as an electron donor. Okay. So it is a reducing agent. And what this copper is doing? It is moving from +1 to 0. It is moving from +1 to 0. Undergoing reduction. Reduction means gain of electron. So from where does it gain the electron? From the sulfur. Okay. If something is gaining the electron, it is called as reducing agent. Sorry, oxidizing agent. It is an oxidizing agent. So it is gaining the electron, accepting the electron, right? Copper is accepting the electron. So it is an oxidizing agent. Clear? Able to understand? Any doubt? Shall we go for the next? Electron acceptors are oxidizing agent. Electron donors are reducing agent. Okay. Shall I move to the next? Shall we solve one question? Are you all ready? Okay. So here is the question. In this reaction, the reductant is, so what is meant by reductant? The reducing agent. So we have to find out the reducing agent from the given 4 options. Okay. So can you find out? So this is the reaction given. Find out the oxidation number of each element in the reaction. So first find out the oxidation state of carbon in the first compound. For carbon, it is C2O4 2-, right? So how will you find out for carbon? So there are 2 carbons. So answer is H plus. Okay, let's check. What is oxidation state of carbon? 2x. 4 into -2 is -8. And it has gained 2 electron. So it is +2. So 2x is equal to 8 minus 2, which is 6. And x is equal to 6 by 2. It will be 3. So oxidation state of carbon is +3. And for oxygen, -2. What about for manganese? MnO4-. Can anyone find out the oxidation state of manganese? We have 4 oxygen. 4 into -2 is -8. And since we have 1 minus here, 1 electron has been gained. So +1 equal to 0, x is equal to 7. So for manganese, it is 7. For H plus, it is +1. And here for manganese, it is +2. And here if you calculate for carbon dioxide, for carbon, it will be +4. That's all. Okay, and for hydrogen, it is +1. For oxygen, it is -2. Okay, so for carbon, +3, manganese +7, and manganese in product side is +2, and carbon in product side is +4. So now you observe the oxidation number of carbon. It is moving from +3 to +4. Tell me whether it is oxidation or reduction. It is moving from +3 to +4. Tell me whether the carbon has undergone oxidation or reduction. It is increase in the oxidation number. So what it is called? What it is called as? Guys, tell me. It is moving from +3 to +4, right? Increase in the oxidation state. It is called as oxidation or reduction. Oh my God. Did I ask you any difficult question? Yeah, very good. It is oxidation, right? It is oxidation. So carbon is undergoing oxidation. And what about manganese? Manganese is moving from +7 to +2. decrease in the positive number, decrease in the oxidation number. So it is called as reduction. Yeah, it is called as reduction. Okay. So the one which is undergoing increase in the oxidation number, okay, is called as reducing agent. Okay, this reducing agent. So in this reaction, C2O4 2 minus acts as a reductant. That is the reducing agent. Okay, since it is moving from +3 to +4, how does it move from +3 to +4? By losing one electron, right? It is an electron donor. C2O4 2 minus is an electron donor. One electron has been donated by C2O4. So electron donors are called as reducing agents. Reducing agent. So the correct answer is option A. Can you all able to understand? Can you all able to understand? Okay. Yeah. So now let's go for one more question. What is the oxidation number of chlorine atom in HClO4 and ClO4 minus? So I have got two compounds. Okay. So can you find out the oxidation number of chlorine in both the compound? Go for the first. Find out the oxidation state of chlorine in HClO4. And this is a structure, HClO4 structure. You can find out the oxidation state by seeing the structure, or you can calculate by keeping chlorine as X. So let me see who is going to find out the answer first. Did you guys get the answer? Yes or no? Are you getting +4, my dear? No, it is not +4. Try once again. Try once again. Try once again. Look into the structure and see. We have oxygen bonded with chlorine, right? So we know that oxygen is more electronegative than chlorine. Yes, exactly correct. Exactly correct. Very good. +7 is the correct answer. So oxygen will gain the electron and chlorine will lose the electron, right? So there are 3 double bonds. Okay. So in each case, we will have +2, +2, +2 for chlorine. And for chlorine oxygen single bond, it will be +1 and -1. So the total charge for OH bond, if you want to take, it is -1 and +1. So the total charge acquired by chlorine is +7. Okay. And what about for ClO4 minus? ClO4 minus. If you lose it, if the compound lose that hydrogen, it will get ClO4 minus charge. So anyway, the charge of chlorine is going to be same only, right? So again, it is going to be +7. So you can draw the structure and separate the charges like this, and you can get the answer. Otherwise, you can go for the calculation. Okay, we all know that hydrogen will take +1, and we are going to find out the oxidation number of chlorine. So +1 plus X. And here for oxygen, for each oxygen, it is -2. So there are 4 oxygens. So 4 into -2 is -8, which is equal to 0. And X is equal to 8 minus 1. So it will be +7. So like this also you can calculate. Okay. Coming to the second compound. So I have chlorine, which is X. So there are 4 oxygens. So 4 into -2 is -8. And we have one minus charge, right? It means it has gained one electron. So +1 is equal to 0. So again 8 minus 1 will come out to be +7. Can you all able to understand? Can you all able to understand? Yeah. Yes, great. So now I will give you one more compound. One more compound. You try to find out the oxidation state. Okay. So K2Cr2O7. You have to find out the oxidation state of chromium in this compound. Can anyone find the answer for this question? Find out the oxidation state of chromium metal in K2Cr2O7. This is another question. Find out. Minus 3.5. No, no, Bindu, it is not minus 3.5. Go ahead with the calculation method itself. What is the oxidation state of potassium? Potassium is a first group element, right? It belongs to group number 1, right? So for all alkali metals, potassium is an alkali metal. For all alkali metals, the oxidation state is +1. So that is what we have discussed in the rules, right? All alkali metals will take +1. All alkali metals will take +1 charge. So there are 2 potassium. So it is +2, right? So it is +2. Bindu, at last you have arrived at the correct answer. Very good. So for each potassium, you have to give 1, 1. So it is +2. And since we have 2 chromium, Sandhya, you want me to explain HClO4? Yeah. I will explain. Let me complete this K2Cr2O7 story and then I will come to that, okay? I will come. Listen. So we have 2 chromium. So +2 plus 2x. And for each oxygen, it is -2. So 7 into -2 means it is -14, which is going to be equal to 0. So what is 2x? 2x is equal to 14 minus 2, which is equal to +12. And what is x from here? X is equal to +12 divided by 2. So it is +6. Oxidation state of chromium in the compound is +6. Is it clear? Is it clear to all of you? Yeah. So coming to HClO4 story again, hydrogen will take +1. Right? Hydrogen will take +1 charge. And we are going to find out the oxidation state of chlorine. So that's why I have taken chlorine as X. And coming to oxygen, each oxygen will carry -2 charge. Since we have 4 oxygen, it is 4 into -2, which is equal to -8. This -2, which I have written here, is not the charge. Okay, this is not the charge of the compound. This is the charge of the oxygen I have written. It is a neutral compound only. Okay, each oxygen will carry -2 charge. 4 into -2 is -8. And from that, I have calculated the x. Sandhya, is it clear now? Still you have any doubt from this? So we have studied under hydrogen story, right? Oxidation state of hydrogen, mostly it will be +1. So that's why I have put +1 there. And also hydrogen is bonded with the non-metal, right? So hydrogen, if it is bonded with the non-metal, it will carry +1. If it is bonded with the metal, it will carry -1. All right? Yes. Good. So today we have studied about the special case, the homework which I gave you. And we have studied about the stock notation. Then we have studied about some of the compounds, the oxidizing agent and the reducing agent, definitions and examples, and some more examples about it. Okay. So since there were some issues at the back end, so we could not able to complete the other topics today. So in the next session, we can start with the types of redox reactions. Okay. So in the next session, we can start the types of redox reactions. So next session is tomorrow, right? So try to join the class on time tomorrow. We will continue this. Okay. So do you have any doubts from today's class? Do you have any doubts from today's session? Is everything clear? Okay. So please do study. Okay. Try to solve more number of questions. Okay. Try to find out the oxidation number for many compounds. And if you're getting any doubt in between, you can come up with your doubts in the upcoming sessions. Okay. So thank you so much, students, for attending the today's lecture. See you. Take care. Bye-bye. I have launched a poll in between. So you guys can give your answers for all the 5 questions given in the poll, and then you can leave the class. Thank you.